Okay, so again, these equations are either going to have one solution, and that's what we're used to, equations with one solution, like m equals 2 or w equals 4, okay, where the variable can only equal one number. So equations that have that one solution, or it's possible that there is no solution, there's nothing, no number that we could use for the variable to make it work. Or it's possible that the equation has all solutions, meaning you could use any number you wanted to and replace for the variable, and the equation would work out. Now these equations are going to look really similar to the equations that we did on assignment 10, where you had a variable on both sides of the equation, okay? So the first equation I'd like for you to write in your notes is 25c plus 74 equals 23c plus 92. Now this one's going to be really similar to the type of problem that you had on the last assignment. I wanted to kind of start off with this. We do not have to distribute. We do not need to combine like terms. So just by looking at this equation, I know that it's only going to have one solution, and this is how I know. I look at my terms on both sides that have the variable. So on this left side, I have a 25c, and on the right side, I have a 23c. And because the coefficients are different, I know that this equation is going to have only one solution. So I'm going to go ahead and start solving this. If you recall, to solve these problems, first thing you want to do is get rid of the term with your variable that is on the right-hand side. So it's a positive 23, so I'm going to subtract 23c from both sides. That's going to give me 2c plus 74 equals 92. These cancel out. Whoops. What's my next step? Minus 74. So don't get scared off on these problems that have bigger numbers. You're just going to have to think a little bit harder and be a little bit more cautious when you are doing your subtraction. You're not just doing it mentally, maybe, where you really have to like work it out. So that's going to be 18. And then our last step is to divide by 2. So c equals 9. So like we said, I knew from the beginning, before I ever started solving, because there was a 25c here and a 23c here, they had different coefficients, I knew it was only going to be one solution. And my solution is 9. Okay, so I would just put in Google Classroom 9. All right, let's do another one. Let's say you have -5 parentheses 3 plus 2c equals 13 minus 3c. Now before I distribute, there's nothing I can do before I distribute, okay? That has to be the very first thing that you do before we ever start looking on each side or moving things around. So let's distribute this -5. -5 times 3 is?
-15.
Good. -5 times positive 2c?
-10c.
-10c, excellent, equals 13 minus 3c. Okay, so I don't have any more distributing to do. I don't have any combining like terms to do. So again, I'm going to look to see my terms with the variable. My coefficients are a -10 and a -3. They're different, correct? Mm-hmm. So that means there's only going to be one solution. So I can go ahead and start solving it just like we did in the last problem. What's my first step going to look like to solve it? Add 3c. So we want to get rid of this minus 3c, so we're going to do the opposite and plus 3c on both sides. So that's going to give me -15 minus 7c. -10 plus 3 is a -7. Different sign, subtract. Okay, equals 13. Next step is to do what? Add 15, good. So 15s are gone, that leaves me with a negative 7c. Some people struggle with when they have it written, when it's written like this, they just bring down 7c. So don't forget that minus sign in front of your 7. It has to be there or you're gonna get yourself messed up. Equals 28. Remember we talked about these answers are not gonna have decimals and stuff. So 7 and 28, that works well together. You know, we're on the right track. Divide by negative 7, not positive 7. So your answer is?
-4.
Negative 4, great. So far so good? Okay. Next problem. How about we have 7 parentheses 2w plus 1 equals 14w plus 7. Alright, so before we worry about anything, let's distribute. 7 times 2w and 7 times 1. What do you notice?
Same.
Equal each other.
They're exactly the same. So 14w over here, we have a 14w over here, and also they have the exact same constant. Now, your terms could be in a different order. It's possible that maybe you wrote, but that means the same thing. You can switch the order around of your terms, okay? But if your terms are exactly the same, this would be an equation where your answer would be all. Okay, all solutions. No matter what number you put in for W, it would work. You could put W is 0, W is 2, W is -5, W is 1 million. It wouldn't matter, okay? Because both sides of the equation are exactly the same, it's all solutions. So in the Google form, you would just write or type in the word all. Does that make sense? Okay. Another one. How about you have 5v plus 3v equals 2 parentheses 4v plus 2. Alright, so one thing that I notice about this equation is that I have parentheses over there on the right. That means I need to distribute on the right. But what can I do on my left-hand side?
Add the 5 and 3.
Good, I can combine like terms here. So if you can combine like terms, you want to go ahead and do that. 5v plus 3v is 8v. And then on the right-hand side, I'm going to distribute that 2. So 2 times 4v is 8v. And 2 times 2 is 4. Now I notice that my 8v's are the same,
So,
but does both sides have plus 4?
no.
No. So in this type of equation, your term with the variable, that's the same, but your constant is different. And if that's the case, then it's no. No solution possible. There is no number
No.
that you could replace v with and make this work. V can't be 0, V can't be a negative number, V can't be a positive number. It's impossible
No.
for V to be anything in this workout. Does that make sense?
Yes.
Because the reason, for those of you that are like, well, why? If you were to subtract 8V from both sides, 8V minus 8V is 0. 0 equals 4? No. So it's impossible, okay? Alright, so you've seen the 3 different types. Let me give you one now.
No.
And you kind of think about if it's going to be one solution, no solution, all solutions. You try that one. Alright, so before we decide anything, we have to distribute. We have to simplify. There's nothing we can do over here, no terms we can combine or anything like that. But on the right side, we can distribute. So 3 times 2 is 6. 3 times m is 3m. So I notice this has a 3m, this has a 3m, this has a 6, this has a 6. So even though the terms are in a different order, it's still exactly the same thing. So my answer is all. Very good. So when they're exactly the same, even though the terms might be in a different order, your answer is all. You do not have to do anything else. You don't have to work it out any further. Question?
On the Google form, are we putting all, no, or one, or are we putting the answer to the...
You're typing the word all, no, or -4.
So if it's one, you would type the answer.
If it's one solution, you would write the answer, yes. I understand. I thought you were saying if the answer is 1. I get it. If it has one solution, then you would type whatever the solution is.
Yes.
Okay, yes, we're on the same track. All right, how about one more page? Okay. What if you had Okay, so first step would be to distribute. So we're going to get -8h minus 26 equals 37 plus 13h. We might have a decimal in this one. I don't know, maybe not. We'll see. No, we don't. No, we don't. No, we don't. Yes, we do.
I didn't get one.
We'll see. All right. Maybe we don't. I don't know. I'm trying to do this all in my head. All right, so one thing I do notice, though, is that on the left-hand side, I have -8h, and over on the right, I have 13h. So that means I need to continue. This is not all solutions or no solution. I need to continue. So I'm going to get rid of that 13h. It's a positive 13h, so I'm going to subtract 13h. So -8, -13, same sign, sum, same sign. So -21h minus 26 equals 37. Next, I'm going to get rid of minus 26. So I'm going to add 26 to both sides. So -21h equals 63. And lastly, I'm going to get rid of this -21 by dividing by -21, and h equals what? 3 or -3? -3.
What I got.
Okay, so for this problem, you would simply enter -3. Don't put h equals, but just -3. Okay? All right, let's talk about the last type of problem. I want you to try to draw a square, okay? So it's important that this is a square. What is something about a square that's important to know, a quality about it? All sides are equal, okay? So it's important that we know that this is a square, this is not a rectangle. And if I said that the bottom part of the square is 4m, and the side is 36 minus 5m, how could I figure out what m equals? And then figure out like what each side equals. How could I figure that out?
4m equals 36 minus 5m.
Good. So you guys just told me that squares have, all the sides are equal. So we're saying that this side is equal to that side. So that's what our equation would look like. Now, would it matter if I wrote 36 minus 5m equals 4m?
No.
No, it wouldn't matter. It doesn't matter which side these are on, okay? Remember, you want your it's gonna be one solution because our coefficients are different. So we want the variable over here on the left. I'm gonna get rid of this by adding 5m. So that gives me 9m equals 36. So what does m equal? 4. Now that's what I'm gonna be looking for, that m equals 4. But just to prove our point, this side, 4 times 4 is 16. So let's make sure that works out to be 16. This would be 36 minus 20, which is 16. That worked out. Okay, I'm gonna give you one to do, and then that'll be it for our notes today. Not too bad, right? Again, this is a square. This is a square. Yep, only for squares. I guess you could do it for like a equilateral triangle. It's an equilateral triangle, all the sides are equal, but you're only gonna work out these kind of problems for a shape that has equal sides. Those are called regular polygons, by the way. When all the sides are one length, it's called a regular polygon. If they're different lengths, it's called irregular. Like a rectangle is irregular. Did you get that R equals 8?
Yes.
Great. Now, again, it doesn't matter which side you put on the right and which side you put on the left. I think it's easier to put the side that has just the term with the variable by itself over here on the left, but you can work it out either way. It's gonna work. Okay? That is it. Let me turn these notes off. Yay.